Hello everyone. In this session, I am going to discuss about the hydrostatic forces on surfaces. Hydrostatic forces means hydro means it is a fluid, static means when the fluid is stationary, and forces. Okay, due to that, the fluid force when it is stationary, what are the forces are acting? Those are called as a hydrostatic forces. And on the surfaces we are going to take that means the submerged surfaces which are there on that the what are the forces will act by the fluid when that fluid is static, that we are going to discuss that one. In this I'll discuss these definitions concerned to that hydrostatic forces. Those are pressure or intensity of pressure, total pressure, and center of pressure. This I will discuss. First I will take the definition of these, and later I'll actually how the forces will be acting we'll discuss. Here first the pressure or intensity of pressure. The P, it is fluid pressure defined as the force per unit area of the application. Okay, this is a concern to the fluid. It is a pressure acting on the particular area, and that can be given as the pressure is a force per area. And units for this pressure, Pascal or Newton per meter square. As earlier we have taken this one in terms of bar or in terms of the of Hg or a millimeter of water head. That also we are going to take as units for the pressure. Then next is that the total pressure. The total pressure is the pressure, whatever the pressure force is there which is acting on any of the submerged surfaces, that is called as a total pressure. The whole pressure which is force due to the pressure will be acting on the submerged surface, that is the total pressure. This is that force exerted by the fluid on the contact surface of the submerged surfaces. When the fluid comes in contact with the surfaces, always acting normal to the contact surface according to the Pascal's law. Whatever the pressure is there, that the pressure force is there which will act normal to the surfaces, and its unit is Newton. It is a force, and that's why its unit is Newton. Then center of pressure, that is called as a CP, and it is denoted as the H bar. H bar, that one. And it is defined as the point of application of total pressure. At what point? Okay, whole pressure is summarized to act. That is called as a total pressure on the contact surface. The submerged surface may be either plane or a curve. The submerged surface may be of any shape. It may be plane surface or it may be curved surface. In case of plane surface, it may be vertical. The plane surface may be vertical, horizontal, or inclined in case of the plane surface. Hence, the above four cases may be studied for the obtaining total pressure and center of pressure. That means here the plane surface of three types: vertical, horizontal, and inclined, and curved surface. For these four types of the surface, submerged surfaces, we have to find the total pressure and the center of pressure. And it is the distance from the surface. Usually, this is center of pressure is the distance from the surface. Okay, from which on that surface, the point where the total pressure is acting. And here, these whatever the pressures are there, the submerged surfaces usually concerned to the construction of the dam and the construction of the dam gates. All these are taken into consideration, and these total pressure and center of pressure are very important while studying about the dam construction and about the dam study. And here, the center of pressure means what? Actually, by considering the one of the imaginary body and submerged under the water, we can take here the center of pressure. What is there? Whenever a static mass of fluids comes contact with the surface, the fluid exerts a force upon the surface. Whenever the static fluid is there, even though it is not moving, it is a static, stationary. and if it's coming contact with the submerged surface, it will exert a force upon that surface. The point at which resultant force act is known as the center of pressure. The point at which the resultant force of that one for the whole surface, the resultant of that force if you take, and that resultant force acting at that particular point, and that point we'll call as a center of pressure. Here this an arbitrarily chosen surface, and on that surface the particular point here the total pressure, okay, at the resultant force is acting at this point, and that pressure whatever is there we'll call as a total pressure. The resultant pressure what is force what is acting, that we'll call as a total pressure. And for this submerged surface, this submerged surface, this is the center of gravity of this surface, but the center of gravity is not the center of pressure, because here this is a submerged surface. At the towards the bottom the more force is acting because of the weight of the fluid according to the Pascal's law of thermodynamics. The pressure will be increasing in the downward direction, and that is due to the weight of the fluid which is above that point. That's why reason the pressure will be, the force will be increasing in the downward direction. More force will be there in the downward part compared to the upward part, upper part. Okay, here this is the x bar is second cg, and this is the center of pressure. This is the distance from the surface up to the point at which the total pressure is acting, and this center of pressure will take the distance as a h bar, the what notation we have taken. And by this one for the different surfaces we can find the total pressure, okay, resultant force which is acting on the any particular surface, and the point of application of that total pressure, that is called as a center of pressure, we have to determine for the different surfaces. And in the further session I am going to discuss the expression for the finding of this total pressure and center of pressure for the different surfaces like a horizontal, vertical, and inclined plane surfaces and the curved surfaces. For all four, the how the this expression is to be derived for the particular surface. I'm I will discuss in the further sessions. Thanks for watching. If you like, share, subscribe, and comment.